So I would suggest we get started. Welcome to this session at TechEd here in Madrid. I'm really glad that so many people came to this topic, continuous integration in the cloud, because the cloud, this is really where my heart beats for. I have been at the PDC where the Windows Azure Cloud was originally launched, and this was the time when I was founding my current company. I'm an Azure MVP. I'm not an employee of Microsoft. And we immediately threw away our entire business plan and moved our company in the cloud. So my own company, everything that I show you today, we live that, we breathe that every single day, and the entire presentation that I'm going to show you here is done in the cloud with tools from the cloud. What makes me a little bit nervous because of the network. So if the network breaks down, we have an early ending afternoon in this session. So let's see, let's hope the best. My name is Rainer Stropek, as stated here in the slides. I'm an Azure MVP for 3 years now, and let's get started. What are you going to see in the next 75 minutes? First, let me point out, I will reduce PowerPoint as much as possible. I promised in the session description to do a demo-heavy session, and this is exactly what I'm going to do. We'll spend maximum 2 minutes in PowerPoint, 10 minutes in PowerPoint, maximum. Maybe we'll manage to do it in 5 minutes, depends on your previous knowledge. So what I want to focus on is demoing continuous integration, Windows Azure websites, and Team Foundation services in one integrated sample. We will start from the very scratch. We will create a new application. We will set up continuous integration. We will customize the build workflow that runs in the cloud. We will build custom-built components that are used by the build server running in the cloud, and we will publish live running Windows Azure websites during this, hopefully during this next 72 minutes. Let me ask a question to you. Who is a little bit, at least, familiar with Windows Azure? Very good. Who is at least a little bit familiar with Windows Azure websites? Okay, third, something like this. Who has already tried or is already using Team Foundation services, Team Foundation server in the cloud? Also, let's say 25%, 30%, something. Okay, so what we will start with is a very short integration, a very short description, what continuous integration is all about, a very short demo, what Windows Azure websites is all about, and then we'll go into the big integrated demo. First, continuous integration. This is the main topic of this talk. So what is continuous integration and why is it helpful? Essentially, continuous integration consists of a few parts that I will name based on this slide. First, you have a code repository and you have a kind of main branch that you want to build over and over again. Next one, you automate the build. Whenever you check something in, you want to trigger the automated build, typically based on your main branch. You use a dedicated build server that is doing the build. You make the build self-testing. That means the build result is quality assured automatically, so you know whether it makes sense to deploy the build results at the end of the build process. You really build and deploy, as we'll see in a minute, with every single commit on typically the main branch, or if you want, even a developer branch or a feature branch. This is what continuous integration is really all about. Automated build, automated quality assurance, automated deployment. And our goal is to use an existing service in the cloud to do that. Because if you set up continuous integration in your own office, you have to do a lot of things. Just to point out a few of them. You have to plan, deploy, and run Team Foundation server. You have to plan, deploy, and run multiple or a single build server. You have to automate the build process yourself. You have to plan, deploy, and run your web servers, maybe even web farms, and it goes on and on and on. And finally, somewhere, you develop your solution. And the idea of Team Foundation services is to turn that around, to put your development effort in the center and use an existing platform, the cloud, to do continuous integration for you. So I want to show in this demo how we can create a new TFS project, set up continuous integration with automated build, with unit tests, with deployments, using the features that Windows Azure give us, so that we as developers can focus more on our core job, and this is developing our solution. So, what is this Windows Azure Websites all about? Windows Azure Websites is the environment where we will run our web application. Windows Azure Websites is a platform as a service offering from Microsoft for running any IIS-based application. IIS-based is important. Do you need to use .NET? No, not absolutely. You can use other technologies too. Please visit windowsazure.com for details. But in my session, I will use ASP.NET MVC4, the current version of MVC, to build a small web application and deploy it. You don't have to set up the operating system. You don't have to maintain the operating system. You don't have to maintain IIS. You don't have to maintain load balancers and things like that. It's all done for you. It's an IIS offered as a service. That's the idea behind Windows Azure Websites. It's super simple to deploy applications there. It's easy to scale them up and down. I don't want to go into any details. You will see it in a second. You can transform your IIS web server into a web farm within 1 or 2 seconds. And you can scale it down, for instance, during night when you have less traffic, again, within a few seconds. And this one's important, you have a persisted storage file system. So you can, for instance, run a file system-based content management system in Windows Azure Website that stores your, let's say, images on a local disk and serves web requests from this local disk. This is fully supported with Windows Azure Websites. That's a big difference to compute services. Maybe you know these services, some of you. This is a different part of Windows Azure. Windows Azure Websites supports this persisted storage. And that's it. I promised you a demo-heavy session, so we will immediately go into Visual Studio, and I will show you Windows Azure Websites and how you can work with it. So I want to repeat what I said at the beginning. I will spend 90% of the rest of this session in Visual Studio and in web browsers and so on. I know that the fonts are a little bit small and so on. We have a big screen. If you want, there are a lot of seats free in the front rows. It will be easier to read the samples and the code. Wherever I can, I will zoom in, but in some situations I can't. So, this is the Windows Azure portal, as most people might know it, and let's start by creating a new website. And the first thing you could do, you could select from gallery here, and you don't have to develop a single line of code. You can choose from a lot of pre-existing content management system blogs and so on. I will not go into the details here. This, if you want to try it, you can set up your own WordPress installation with a few clicks and you are up and running within minutes. But I will focus more on the development part. And the most simple way of accessing a Windows Azure website is by using FTP. So let's try that. Let's create a new website here. Let's call it my TechEd Europe 13 demo site. North Europe, because we are in Europe here. Let's create the website. And those of you who are used to other parts of the Windows Azure platform, for instance, cloud services, might think, okay, this will now take 5 to 10 minutes. Well, it will not, because Windows Azure websites are up and running really within seconds. So let's go into it. And if we try to launch this site, yes, the site is up and running. It's there. It's not very interesting, because it just said, okay, it's successfully been created, but nothing's in there. So let's do the most simple thing what we can do with the Windows Azure website. So run Notepad, write some HTML code. I don't know, hello TechEd, for instance. That's it. Save this file. For instance, in the documents here, let's call it hello teched.htm. And let's try to put it in our Windows Azure website. But first, let's turn our website not in a single server, but into a web farm. With a click of a mouse, I can duplicate my IIS, run it on 2 servers, put a load balancer in the middle, and we just have to hit save, and that's it. The system is warning me that this will incur costs. Yes, that's fine for me. And now we have a web farm. Even though we have a web farm, we can use simple FTP to upload our HTTP file and launch it from any web browser that we want. Let's try this. I will copy the FTP host name here and use, in this case, FileZilla. Maybe you know it. It's a very popular open source FTP client. The user is also stated here in the portal. That's it. And the password is stored in a password keeper here. So I will copy it and insert it and hit quick connect. Now we are connected to our Windows Azure website, and although we have a cluster, we have 2 servers in our Windows Azure website, we can simply deploy our Hello TechEd HTM by dragging and dropping it. That's it. It's just drag and drop, and that's the deployment process. That's the most simple deployment process you could imagine. If we now run our site, it still says, well, nothing's there, of course, because I have to change the URI, hello teched.htm, and here we are. Here is our deployed site. So this is the hello world of Windows Azure website. Super simple setup of IIS, scale down, scale up with a click of a mouse button. There are dedicated sessions that show you all the details of Windows Azure websites in this conference. I will not go any deeper because I want to show the integration part with TFS. We used FTP, but to be honest, in practice, this deployment mechanism is not very funny. If you build a complex MVC application, you have to have something more powerful. And the next powerful thing from FTP is directly, but still manually, deploying an application from Visual Studio. So let's take an MVC application and deploy it directly from Visual Studio to see how this feels with Windows Azure websites. For this demo, I have already prepared a pre-built MVC application. It's called Bee in My Garden. Why did I call it Bee in My Garden? Because in my private life, I'm an apiarist, so I'm holding honeybees. This is my hobby, and I have a blog for the German-speaking audience, bienenimgarten.wordpress.com. There you can see me wearing a funny suit and caring for my honeybees in my garden. And for this demo, I will run it locally in the debugger in Visual Studio. No cloud involved in the moment. I run it, and what we should see in a second is my blog. Serviced from a small SQL Server database. In fact, it's local DB running on this local machine here. Give it a second. Yeah, here it is. You see, you see me. This is MVC, so we can say /blog /index/2, for instance, and then we get a specific blog entry. And if we ask for another blog entry, 99, for instance, we get a 404 because this blog entry has not been written yet. Okay, this is the sample. This sample is ready-made, so we don't have to implement it. This session is not about MVC and ASP.NET, just a very brief code walkthrough. Our project consists of 3 different parts. First one is the data access layer. I'm using Entity Framework. Let me zoom in a little bit. I'm using Entity Framework code first. So the application creates the database structures it needs when it connects to the underlying database. First one. Second one, it uses some unit tests. Let me zoom in again. I have written 2 unit tests. Can you remember? Continuous integration. We need to have automated unit tests. These 2 unit tests are testing our MVC controller to make sure that our blog engine really works fine. And finally, we have the MVC application down here. I don't want to go into the details. In my blog, that's www.software-architects.com, you will see a video with this sample, and you can also download the entire source code. So just look up my name, and I'm sure you will find my blog, and there you can download the source code if you are interested in the implementation of this MVC part. But now, you know what? Let's deploy this application to Windows Azure website. This time, it's not as easy as before. We cannot just take it and FTP it into the cloud. We need something a little bit more advanced. And here comes Visual Studio and Web Deploy into play. Let's create a new website. Creating a website is a matter of seconds, so it's no problem to create it. Let's call it Be in My Garden WAWS for Windows Azure website. Just to make sure that we always know what we are talking about, I add this postfix here. So create the website. Of course, this website, again, will be empty. And we have to deploy our code there in a second. Here we are. I'm now here in my Windows Azure website, and it's important, or there is a nice feature here that is called linked resources, where I can tell Windows Azure that my website needs, in order to successfully run, a database. You can link these 2 things together, and so Windows Azure, for instance, could warn you if you try to delete the database that is linked to a website. Windows Azure will say, hey, are you really sure you have linked the website with this database? Or on the other hand, if you delete the website, Windows Azure can ask you, hey, do you want to drop the database too? You know, you get the idea? This is the idea of linked resources, and we can try it because I have already created an entirely empty database in the cloud in SQL Azure. So we link an existing resource, we click SQL database, and you can see I have 4 databases set up in my account, and one of them is called Be in My Garden SQL. It's empty. Believe me, we don't talk about SQL here. It's just an empty database. The login name, I've prepared a login name. Here, let's copy it. Here we are. And we need a password. This password is not secret. It's just for demo purposes. That's it. It will take only a few moments, and then Windows Azure knows that my Be in My Garden website is linked to the Be in My Garden SQL database. Here we are. Very good. So now how can we deploy this application into the cloud? We are really only a few clicks away because, thankfully, the Windows Azure portal allows me to download a publish profile that can be consumed by Visual Studio. So I just click Download Publish Profile here, save it, go to Visual Studio, here. On the web project, I hit right mouse click Publish, and now we need to specify exactly the publishing profile that we just downloaded from the web. Import it. Here we are. Here is the downloaded profile. You see everything set up for you. Of course, you could have copied all these things like server name, and also you could copy them manually from the website to Visual Studio, but it's much more convenient to download the publishing profile. But now comes the important part. I hope maybe you can't read the details here, but here you see a connection string. What Visual Studio now does is it says, hey, you know what, Rainer? You have set up an MVC application. In this MVC application, you have a web.config. In this web.config, you have a connection string. This connection string points to a local database, local DB. If you deploy this website to the cloud, it will not work. Why? Because the website doesn't have a local DB. But the target website is connected to a SQL database. Do you want me, during the deployment process, to rewrite your web.config file and change it from your local SQL server to the SQL Server in the cloud. And this is exactly what I'm going to accept. So changing the database connection, doesn't matter if you use SQL Server or MySQL or any other database system, is really one click in this Visual Studio publishing profile. Next, publish. Again, the beauty of Windows Azure Website compared to, for instance, cloud services is that it's incredibly fast. It should really be up now. Now? Well, give it a second, you know, ASP, first hit, here we are. We are running the entire application in the cloud. Please keep in mind what just happened. We compiled the application, we deployed all the packages, he deployed all the necessary, he got the necessary NuGet packages, he rewrote the web.config file, he sets up the load balancers, everything's there. He created the database, the data structures, he inserted some sample data, the 3 blog items that you see here, and we are already running in the cloud, live in production. And if, I don't know, the entire world wants to hold honeybees and is interested in my blog, it's just click scale. Watch this beautiful animation. Instance count, change it to, I don't know, multiple instances here, 2 instances or whatever, and we can scale up and down just as we want. So the first step that you have seen is the simplest way at all. It's FTP. If you, for instance, use a technology that doesn't need to be compiled, for instance, if you use Node.js, JavaScript on the server, you could deploy with FTP. Why not? You could even automate your deployment using FTP. Why not? But if you need something that is a little bit more complex, like ASP.NET MVC, that needs a compiler and things like that, you need a tool. And this tool is Visual Studio. And by understanding the deployment profile, it's very simple to connect your Visual Studio with your Windows Azure website. And the last point in this demo is we're going to take a look here at the publishing profile XML. That's really the XML that's created under the hoods when you connect your Visual Studio with your Windows Azure website. And down here, for instance, you see that it inserts an MS deploy parameter value that changes the underlying data source during deployment. Well, some of you might say, I'm not entirely happy that my production SQL Server's password is now stored on every single developer machine because it's now in Visual Studio, and we don't really want that. And that brings us to the next step, continuous integration. Wouldn't it be nice if we could still use Visual Studio for local development? And when we are done, we just check in our sources. A build server would recognize that, take the sources, build it, and deploy it from the build server. You know what I mean? And there, of course, you can safely store connection strings, and you can change the build process, and you can standardize building and deploying throughout your entire team. And that's the next step. But for this, we need a build server. We need a platform for managing our source code, and in the Microsoft world, many people use Team Foundation Server for that. So let's go back to the slides for a second, because that brings us to the next step. It brings us to Team Foundation Services. Very quick overview. There are dedicated sessions for Team Foundation Services. So if you want to know the details, please go there. My goal is not to make you a Team Foundation Services expert. My goal is to give you the big picture of continuous integration, Azure, and Team Foundation Server. But still, you might wonder, hey, what is this Team Foundation Services all about? First one, it's a TFS in the cloud, operated and run by Microsoft. It offers a broad functional reach. Nearly everything that you know from local TFS is supported in the cloud. Well, nearly, not really everything. It's essentially free for small teams. You can use it with teams with less or equal 5 team members absolutely for free. And it will be part of certain MSDN subscriptions. So if you have an MSDN Universal subscription or whatever, you already have a license for Team Foundation services in the cloud. The build process that I will concentrate on today is still in preview. So in preview, it's free and it's not capped. Okay? We don't know the prices when it's there. Well, today and tomorrow and this week at Build, every hour we hear new announces. Please open your ears. Maybe you will hear something. I don't know. I really don't know when it will become generally available. Yes, there are a few limitations for Build and for TF services in general. First one, TF services. You cannot change the, for instance, work item types and forms and things like that. You have to stick with the, for instance, Scrum process that comes from that out of the box. And for Build, an important thing is your build process has to finish within 1 hour. That's the upper limit. If your build takes longer than 1 hour, and with build I mean build plus test plus deploy, then currently you can't use Team Foundation Services Build. With that said, I promise you I only have one final slide left, so the rest of the session will be again Visual Studio. Now let's create a Team Foundation Services project. Let's do that. If you want to set up Team Foundation Services, let me zoom in a little bit. You go to tfs.visualstudio.com, you register with your Microsoft account, and if you've done that, you can quickly and easily create a new team project. Of course, I will call it Be in My Garden TFS, just to make sure that we understand what is TFS, what is WAWS. You don't need this postfix TFS. It's just for clearance here. Create it. It will only take a few seconds, and then we should have a new team project. In the meantime, I will go to the Windows Azure portal, drop my existing website because we want to start over again, this time not with manual deployment, but with automated deployment. Give the system a second. Okay, it's deleted and recreated. Do the quick create again. Okay, we know the name already. Be in My Garden. WAWS. Let's see. Yes, North Europe. That's fine. Create website. And in a few seconds, we will have both. We will have a project in Team Foundation Services, and we will have a Windows Azure website on the other hand. And our goal is to connect these two things. Let's see. Let's go to Team Foundation Server here, and you see this status message. I think this is one of the greatest things of TFS. It says your project is created and your team is going to absolutely love this. I really think this is a creative status message of the TFS team here. So navigate to the project. We have our Be in My Garden TFS. And just to prove the point, that is really a TFS, very similar to the TFS that you have on premise. Let's go to Work here. I don't know if you're familiar with the current version of TFS, but you can plan your work items. Let's say we have to create a database and we have to implement the UI. And finally, let's make the UI awesome. We have to do some design work, and you see on the left-hand side you have different sprints, so you can create sprints and versions and things like that, and then we can use drag and drop and, for instance, create the database in sprint 1 and implement the UI in sprint 1, and let's make the UI awesome in sprint 2, and then go, for instance, to the board and do all the things that you are used to in TFS locally. You can plan your team, you can use the Scrum template, you can use the Kanban template as we do, for instance, internally. It's just like a TFS on premise. And we just created it from scratch. And I think this is a great thing if you can live with the restrictions, of course. Now, this is the work part, but for our case, We want to check in source code and run a build. So we need to integrate websites with Team Foundation services. And this is incredibly simple, really. You go to your website, here, Be in My Garden, WAWS, and down here it says set up deployment from source control. Let's do that. You see there are a number of options you have for deploying it. You can use Team Foundation services. We'll go into that in detail in a few minutes. But you can do crazy other things. You can do Git. Of course, this is not crazy, but Dropbox is a little bit crazy. You can connect your Dropbox account with your Windows Azure website and just, I don't know, take some photos and HTML files, put it in your Dropbox, and from there, Windows Azure website will pick it up and deploy it automatically in your Windows Azure website account. So you can do, yes, continuous delivery via Dropbox. I mean, we don't do that, but it's possible. Okay, we use Team Foundation services here. It asks me for the name of my Team Foundation server. In my case, it's Rainer Demo TFS. If you're not sure what your name is, you will see it up here in the URI. It says Rainer Demo TFS. Authorize it. Now, OAuth 2, the two systems talk to each other and say, hey, I have a life ID that is called Rainer@timecockpit.com. Do you know this guy? Yes, I know him. Let's ask him if it's really him who wants to perform the connection. And here, one time, I have to accept it. And with the click of this accept button, the integration of Windows Azure websites and Team Foundation services is set up. The final question that I have to answer is, which project do you want to connect this Windows Azure website to? And in our case, of course, it's Be in My Garden TFS. We have created this project a few moments ago. Let's wait until the connection is established. Only a few seconds, I promise. And here we are. Now, we have connected them. What does that mean? What does that mean they are connected? That means that we have already successfully set up continuous integration. As soon as we check in a project into this Team Foundation services server, it will automatically trigger a build, and it will automatically execute unit tests, and it will automatically deploy the build results if the unit tests were successful. Let's try that. Let's run Visual Studio directly from here. It opens up Visual Studio immediately connected to the correct Team Foundation services instance, so we don't have to do any nifty configuration stuff here. It's automatically done for us. Let's take a look at the Source Control Explorer. I'm very sorry I cannot zoom in here. I'm in a virtual machine, and zooming is a little bit a problem. Be in My Garden TFS. Let's do a get latest version and open this in Windows Explorer. I will copy exactly the local solution that we have used a few moments ago here in this instance of Visual Studio. So I will just copy the local code into a directory that is mapped to Team Foundation server. So, copy it. We don't need the packages folder here. Copy it and put it into our source Be in My Garden TFS. That's it. And let's now open the same solution that you have seen from this part of the file system. Visual Studio will open it, and we have it here in Solution Explorer. It looks exactly the same, but now we can just say, hey, source control, add solution to source control. Now we can add our files to Team Foundation services. This is what I've now done. I copied the files and added them to our code repository. I have not committed them. They are just added. I have to do one extra step, and please bear with me. I will not describe in detail what I will do now. This will follow in approximately 5 to 10 minutes. Just believe me, it's necessary that we take the templates folder here and I hit finish. Bear with me. In 5 minutes you will know more about this. So, let's go. Save everything. Right click. Check in pending changes. Check in. Yes. And that's it. Now I've checked in my sources. Come on. Yeah, it's done. And by checking it in, a build was automatically triggered. You see? Just who uses a build server on premise today in your company? Okay, then you know this stuff. You know that you have the builds on the right-hand side here. In this case, just by checking it in, it automatically triggered a build. And if the build succeeds, it will run the tests. If the tests also succeed, they will, the entire result will be published to Windows Azure website. Now, wait a moment. Our unit tests, by the way, we can run them locally too, just to prove the point. Let's go to Test Explorer here and run all the unit tests. We have 2 unit tests. Build the solution. Let Test Explorer discover the unit tests. Here they are. Hit the run all, and they are finished. You see? Green checks. That is what we want to see. But let's wait a moment. These unit tests need a local database. We haven't changed the database connection for the unit tests. How can the build server run unit tests that require a SQL server? And the answer is LocalDB. On the build server, you can check that out in MSDN library, it's stated there. On the build server, you have a full Visual Studio Ultimate Edition with all the options installed. So you have LocalDB on the build server. So you can create databases and create tables and do all the things that you need during build in the cloud because LocalDB is there. That's an important point. So we don't have to change anything. It will just work. But we have one big problem. Our website has a web.config file. The website is also connected to our local DB. But on Windows Azure website, we don't have a local DB or SQL server installed. This doesn't work. And the automated build process will finally run the build. It will run the tests. They will succeed. And it will deploy our website, but the website will not run. Because it's at the server where IIS is installed, it will look for a local DB and it will not find it. So again, we have to rewrite the web.config file during deployment. But now we don't do the deployment manually in Visual Studio. We don't have a wizard where we can change the connection string. We need to tell it to the build process. And luckily, the build process supports that. Let's take a look. So go to Team Explorer. Let's refresh this. OK, this build is still running. I can double-click on it, and we see, yes, it's in the middle. We can really stop this build. We don't need it because, as I told you, the website will not run. The web.config file is simply wrong. So we have to change the definition of the build first. This is done by selecting Edit Build Definition here. And this, again, is nothing special for TFS in the cloud. Those of you who know TFS know this configuration page here. You have the process here. But this process now uses a special build workflow. It's called Azure Continuous Deployment 11.SAML. Where does it come from? Now let's take a look. In the Source Control Explorer, you might have noticed that there is a folder which is called Build Process Templates. And there we find our Azure Continuous Deployment.xaml file. This build workflow was automatically created when you established the connection between Windows Azure websites and Team Foundation services. This is a build process that is specifically built for continuous integration with Windows Azure. Okay? So our build definition is linked to this special build workflow, and we will customize it in a few minutes. So let's go back here, and down here, I'm sure you cannot read it in the back rows, but I will read it for you. It says Web Deploy Publish Profile, and this is the key. You can specify here in the options that this build process should use the publishing profile that we have downloaded from the Windows Azure website portal a few minutes ago. Can you remember? Download publishing profile. I saved it locally. It was the XML file that contained the rule for rewriting the database connection. And we can tell this workflow that it should use exactly this publishing profile. And when we do that, the web.config file will be rewritten exactly in the same way as it was when we use web deploy manually. Let's try it. I just select these 3 dots here. I go to Be in My Garden Web, I go to Properties, I go to Publishing Profiles, and this is exactly the XML file that I've shown you a few minutes ago. This XML file contains the rewrite rules that says, hey, change the connection string in the web.config. Hit OK, and maybe, you know what, change the logging verbosity to detailed so we can see what happens on the build server. That's it. Save it. Let's go back to our source control explorer just to make sure that I didn't forget to check in something. Nope, everything's okay. So we didn't change anything. So now we can queue a new build manually, and this build should now work. This build should successfully execute the unit tests using localDB on the build server. It should successfully build the entire application, and it should also successfully deploy the application with a rewritten web.config file that points to our database in the cloud, to our production database or our test system or whatever you want to use there in the cloud. I can show you, you can double-click on it, and you see the request is currently queued. In a few moments, it should change, and we should be able to view the build details. And yeah, now we see the view. I think it's important that everyone sees that, so I will minimize, or I will go away here, and let's see. Let's zoom in. Let's try. I try my very best to not ruin the entire demo. I hope you can now see it from the back rows too. You see, this is the build in Visual Studio, and you see you can take a look what's happening on the build server. We see the progress of the build server, although the build server is running in the cloud and we don't have to maintain it, we don't have to install something. We cannot even maintain it, and we cannot install something. This is a very important restriction. If your specific process requires to change some configuration in the build server, a configuration that is not only copying a file to it, but changing a registry entry or installing certain components in the registry, I don't know what you want to do. If you have something like this, I'm very sorry, you cannot use the build service of Team Foundation Services. That's the idea. You give away a little bit of control, but what you gain is a lot of productivity. That's in the cloud, that's always two things that contradict each other. If you want full control, you have to care for it yourself. If you are okay with giving away control with less control, you will get a lot of platform services where you get a lot of things for free, and you concentrate on what you want to do. Just to give you an idea, what we do in our company, we really design our processes and to a certain degree our software so that we can successfully use these platforms. So we don't say, this is our process, and if the platform doesn't support it, we cannot use it. We do it the other way around. We select our third-party components by taking a look at them. Can we use them for platform as a service? Because it pushes our productivity to a whole new level. That's the idea of platform as a service. In comparison to infrastructure as a service, of course, if you just want the cloud, you can set up your own VMs and configure them as you want, of course. But then you have this little Tamagotchi running in the cloud that needs care for and needs some food, and you have to keep it alive and these things. I don't want these things in the cloud. So, okay, what's up with the build? Let's see. The build is already associating some change sets. You see the tests were run, and now we are ready. You see, the build succeeded. Maybe let's zoom in again because I cannot make this one larger here. Can you see one test run completed? You see the 2 unit tests were executed. I click on it and I scroll down, and you will see the results of the unit test. These are the results from the build server in the cloud. That's an important thing. And finally, If the demo gods are smiling, I can click on this link and hopefully, yeah, here it is. This one was deployed automatically with continuous integration. We have still 30 minutes left, so this can't be all. The next step that I want to go with you is customizing the build workflow. Because you might say, okay, I'm a little bit okay with giving away control about the build server itself, but I need to customize the build workflow. I need to write my own custom build activities. How can I use a custom build activity when I use the build server in the cloud? And this is exactly what we are going to do next. Just to remember, you don't have to write down anything. You can go to my blog here. It says www.software-architects.com, and here you have this entry here. I'm here on a server, so you have the video of the entire sample where you can see it, how I do the sample. You have the entire slides, and here you have the source code. So if I'm too fast and you cannot get all the details that I'm telling you during my session, no problem. Take a look at my blog, and you will see all the details. I see that some people make notes, so let's zoom in a little bit. This is the URI, www.software-architects.com. It's already up and running, so you can, after the session, you can immediately go there and take a look at the details. Okay, back to Visual Studio. I want to do the scenario that I want to build with you in the remaining time is I want to customize the build workflow to enable a fine versioning of DLLs. What does that mean? Typically, a DLL that you build in your Visual Studio project gets a version 0000. Can you remember where the version information comes from? I will show you if you can't remember. You have this properties here, and you have this version file. And this version file, let's zoom in a little bit, you have this assembly level attributes in .NET that says assembly version and file version and configuration and things like that. So these informations are copied into the DLL, and whenever you get a DLL, you can take a look at this version information, and you know when it was built, that it was built by you, and things like that. And what I want to do with you is I want to create a custom build component that changes this version information on the fly during build based on the current date and time. So we get a version that says, I don't know, 2013 for a year, .6, what is today, 626 for June 26th, and some time information. This is the scenario that I want to build with you. But please keep in mind that's just a scenario. With the same process that I will show you in the next minutes, you can customize everything in this build process. If you want to do something else, you can. I'm just taking one example that, in my opinion, a lot of companies do. They automate the versioning of their DLLs. Okay, I have prepared the custom build component that we need. It's called generate version file, and it's extremely simple. It's just a template. I will show it to you. Here it is, generate version file. It consists of a single file, a single class that's derived from code activity. That's all you have to do to write a custom build activity. And you have one important method here. I will not go into all the details. You can read the MSDN library yourself. But the execute method is called on the build server during the build. And this execute method does the following. It takes the current timestamp, creates a version object here, and uses a template file. I will show you such a template file in a second to generate version informations dynamically on the fly during build. What do I mean with version template? Can you remember I had this template file before, a template folder before, where I told you I will not go into the details here. Now is the time that we come back to this template folder. Here you see you have a version file, and it's simply a string.format version file that at assembly version, file version, and configuration has a placeholder. That's everything. So it takes this template file, and where it says bracket 0, it should add the version information with year, month, day, hour, second, and so on. I think you get the point. Okay? Take this template and during build, generate such a file based on the current date and time and use it to generate the assemblies and inject the version information. That's the idea that we want to change in this build workflow. So let's build this. Let's build this code activity. Yeah, it's successful. And let's add this code activity to source control, of course, add it to Team Foundation Services. But now comes an important point. It's not enough to check in the source code for this build activity. For this build activity, we have to check in the intermediate language, the assembly, the DLL. Why? Because this DLL will be used by the build server, by the build workflow on the build server. So the build server needs the existing code activity compiled in .NET. It will not first compile the code activity and then run a second compile using the, you know what I mean. Okay? So it's not enough to check in the source code. We have to check in the binaries too. No problem. Let's go into source control and add bin debug, and let's add DLL and PDB. It's fine for this demo purposes to check in the DLLs and the PDBs, so the debug build. You get the point? You create the code activity and you check in the compiled code activity so that the build server can get all the components that it needs by checking out the source code repository. Okay, let's get in. Check in. Here we are. So now we have the component in Team Foundation Server, and we can now start customizing the workflow. Can you remember where we find the workflow? This was the thing. This is this Azure deployment 11 XAML stuff. Well, it's here in this build process templates, and here was the file Azure continuous deployment 11 XAML. Of course, I can just double-click it. As you might know, in current version of Team Foundation Services, this is a workflow foundation. Workflow who has already had the nice job to customize a build workflow in production? Nobody. Nobody ever customized it. Yeah. It's not very funny, isn't it? It's a long, long workflow. If you want to print it, I think it starts back there, and I don't know if the room is large enough. It's a long workflow. We will not go into the details of all the nifty details of this build workflow. It's not my job to make you a TFS expert. There are a lot of resources out there on the web where you can read the details. I want to show you, again, the integration part with Windows Azure. In order to manipulate this XAML successfully, we need a kind of solution infrastructure around it. So best practice is you create some kind of dummy project where you embed this XAML file. It's just it makes your life a lot easier if you do it and if you don't edit it directly as a file. So I use here, I don't know what, dummy, just to make it very clear that it is just a dummy project. It is irrelevant what's inside of this project. It's just a frame around the XAML file to make it easier to edit it. Add existing item. Which one do we want to edit? Well, we want to edit Be in My Garden TFS, build process template, change from C# files to XAML files, and open it. In order to be able to use our custom build activity, we need a reference to our custom build activity. We have created them together, and they are here in this debug folder that I've already talked about enough. I don't have to repeat that. So let's open up the workflow designer and customize our build workflow. Please keep in mind This build workflow will run in the cloud. It will not run locally in our build server. Let's collapse all, and I go to run on agent, and here we have the, let's see if I can zoom in a little bit. Here we have the initialize workspace, and here is a good idea to change it. You know what I want to do? I want to create, on the fly, during build, a directory, let's call it generated. In this directory, I want to add a version.cs file created by our custom build activity that is used instead of the version.cs file where 0.0.0.0 is integrated. You understand? I want to use it instead of this file. So we have to exchange, we have to drop the old version.cs file that's in the properties folder, and we want to replace it with a version.cs file that is only existing during build. That's the idea. So let's first create the directory dynamically during build. For that, we use the toolbox, and we have a create directory here, drag it and drop it, and here we can change that. We can say we want to generate system.io.path.combine in the sources directory. This is the directory where all the sources lie on the build server. We want to generate, let's call it generated. We want to create a dynamic directory which is called generated. That's it. That's all I have to do. Now the build workflow during build will create this directory. Next one. Inside of this directory, we want to create the version.cs file. But for creating the version.cs file, we want to use the custom build activity. Now, let's take it. It's not already present here in the toolbox because Visual Studio doesn't know that we have created a custom build activity, but it's super simple to make it visible to Visual Studio. We just use choose items here. We say browse. We go to the directory where our custom build activity lives. It's in bin, debug, and here it is. Hit OK, and that's it. Now Visual Studio knows about our custom build activity. Here it is, and I can drag and drop it here. Generate version file. This is our custom build activity. And again, I know I repeat myself, but this is so important for me. Later on the build server, it will find this generate version file custom build activity because we have checked it in. We have checked in the DLL. You get the point? Okay, I see some heads nodding. That's good. So let's configure it. Okay, so that everyone can see, I will again play a little bit with the magnifier here. Here it is. What is the configuration? Automated build. It's just a description. It's nothing special here. What is the file path? Where should the version.cs file be created? It's path.combine. In the sources, in the sources directory, there we decided to generate a directory which is called generated, and there we want to call it version.cs. Okay? This is the target file that should be created. What is the date from which the version information should be derived from? Date time now. Simple one. And what is the template path? Where does it find this template with the brackets and the 0 in it so that it can be used for string.format? Well, I've checked this one in. So let me go into here. Just to make sure that we can remember, here is the templates directory, and here we have this version.cs file. We have to tell our custom build component where it finds this file. Let's go into and do it like this and say path.combine sources directory. What is the name of our project? We called it Be in My Garden TFS. What is the name of the directory where the version file lives? It's called templates. This is just a name that I have chosen. And what is the name of the file? Version.cs. If we would now run the build, exactly this build, on the build server, the version file would already be created. So we have already customize the workflow. But to be honest, it's not very interesting because we create a file, but we never see it. We just have to believe that it's created. We have to do something with it. And this one is a little bit deep into TFS. So those of you who are new to TFS, maybe this one is now a little bit hard to understand, but try to follow me. You can take a look at the video if this is too new for you. I will look for a component here that is called run ms build for project. This is the nice thing here, that we can search in Windows Workflow Foundation. It's searching for the correct one, and just to make sure, for those of you who have never customized the workflow, we are now in level down, I don't know, 17, and somewhere, finally, MS Build is called to build the entire solution. Everything else is maintenance around this one single central command. And there we have our command line arguments, and in these command line arguments we can specify a parameter for the version file. That's just the same as you might know it from local TFS, and this is the reason why I will not go into very much details here, because it's the same as in on-premise TFS. P version file equals, this is a string parameter, so we have to enclose it in double quotation marks because it's Visual Basic, a Visual Basic expression here. And where does it find the generated file? In path.combine sources directory, and generated, because this is the name of the folder that we have chosen, and there we have version.cs. Close it. That's everything we have to do. Now MS Build knows that it should replace the version file 0000 with the version file that was dynamically generated. Please don't go into the very details of this sample. It's just the idea so that you can see it's easy to add custom build components, and it's also easy to add custom logic to the existing continuous integration process that comes out of the box with Windows Azure Websites and Team Foundation services. One last single step is needed, and it's a very important one. If you want to do this yourself, then please, please, please remember this one. It took my colleague Phil Auma and me, I don't know, 5 hours of work because we forgot this important step. This last step is here in the builds folder. There is up here a command that says action. Let me zoom in because that's so important so that everyone should know what's happening here. Here we can see manage build controllers. Just took a second. And here we see the hosted build controller. It's the build controller running in the cloud. And here we can say properties. And here you have this magic property. It's called version control path to custom assemblies. Here you have to tell TFS in the cloud where it will find the DLLs for custom build activities. I told you we have checked in our custom build activity, our DLL. And now we have to tell TFS where we checked it in so that it can grab it from there before it runs the build process. This is a very important step, and I emphasize it in the video so you don't have to write it down. It's there already. I choose here be in my garden TFS. I check generate version file activity, bin and debug, and that's it. I can hit OK, and hit close. Now everything is set up, and if the demo gods are smiling again, let's see if I forgot something. Check everything in. Nope, no pending check-in. No pending check-ins. Let's see if I have it here. Yes, it's already there. Did I save it? Yes, I saved it. So let's queue a new build. Again, this build is running in the cloud. It's queued. And in a few more moments, we will see the build starting. If everything goes right, we should see in the log now our customized workflow steps. We should see that the file is generated. We should see that the directory is created. We should see that MS build accepts the parameter and replaces the version file. And at the end, we can get the DLLs and hopefully see the version information there. Because then we would have proven that we successfully changed the build workflow in the cloud. So last time, it took, I don't know, 3 or 4 minutes. Let's take a look at the build details. Run on agent is already running. While this is running, I can show you some additional tips and tricks. In Windows Azure Websites, you have a folder here, or a menu item that is called Deployments. Do you see it? The Deployments folder here shows you not only the active deployment, this is our currently running build, this deploying here, but it also shows you a deployment history. And sometimes, I mean, no one in this room, but sometimes developers make mistakes. Yeah, you build something, your unit tests do not detect the failure. I mean, again, no one in this room does this, but I heard that it should happen sometime. Your unit tests do not detect the error, you deploy a version and it doesn't work. And the nice thing here is, in these cases, you can click on an old deployment here and hit redeploy. What does redeploy do? If you have successfully set up continuous integration, it triggers a new build with the old sources, so it's rebuilt there, and it's again deployed in the cloud. So you can easily step back one version and deploy the old version to a Windows Azure website to make sure that your, for instance, portal or shopping application is again up and running. Then you can correct your mistake, you update your unit tests, and you can successfully deploy a new version. So this is meant with deployments here. Let's go back to Visual Studio. Yes, a few interesting things are already showing up, and let's see what I did wrong or if I did something wrong. First thing, we have run on agent, and where is it? Initialize workspace, that's fine. Create, where is it? Let's see. I think I did something wrong. Let me see. Yes, I did something wrong. I'm very sorry. I forgot, but no problem. We have enough time left. What I did wrong, I changed the Azure Continuous Deployment file in the wrong folder. I copied it. I didn't want to copy, but I copied it to this application. What I wanted to do is I wanted to add it as a link to keep it in the original location. This one I did wrong. I'm very sorry for that. Please bear with me for 1 second. We will check this one out for edit. Here we are. Paste it, replace it. Yeah. And check it in. This builds. Queue new build. And in a few moments, it should be there. This is also something that I can tell you from practice. Troubleshooting for customized build workflows or custom build activities is not the easiest thing on earth if you have a build server where you cannot remote desktop into. It takes a few trials. You have to get used to how the build server is set up. Maybe you have to read 1 or 2 blog articles. But I mean, what you get is a lot of things that you don't have to care for. This build workflow will hopefully now run, and We will get back to it in a second. Yeah, it's already running. Don't wait for it. Let's quickly go back to the slides, to the summary here, and then we'll finally take a look at the build outcome to prove the point. Windows Azure websites and TF services, Team Foundation services, are really designed by Microsoft to work together. So they really are, I always say, they are a match made in heaven. They are not one island and you have to build the plumbing between them. No, they come to work together. The continuous integration platform that you have seen here saves you a lot of time, because you don't have to set up the build server, you don't have to maintain the build server, you don't have to set up your TFS, you don't have to set up the Internet Information Server and infrastructure for load balancer and so on. It's already there. You give away a little bit of control, and what you gain is productivity. Yes, there are limitations. That's an important one. There are limitations because you have no influence of the underlying platform. You cannot install components at the operating system level. If you have specific demands, well, you can't use build, but you can still use Team Foundation services, but you have to use infrastructure as a service in Windows Azure, for instance, to run your own custom build server. So it depends on the level of control that you need. Let's switch back and see if demo gods are now smiling for me. Here we are. Can I see it? Create directory. Now the correct workflow is running. Generate version file. Very well. No error here. So it worked. The build workflow took our custom build activity and ran it in the cloud on the build server. And finally, if we are really going deep into it, then somewhere in this msbuild.exe command here, we see the parameter for the version file. So now everything should turn out right, exactly as we wanted it. Let's take a look. The build process is nearly done. It's currently associating the change sets. The next step is getting the drop location. And just to make sure that everyone knows what I'm speaking about, if you go to build here in the portal and you take one specific build, this is an old build, this is not our new build, you can download the drop location through the portal. You get a zip file of the resulting files from the build workflow, and we can go into drop files here and we can sort it and we can take a look at our DLL. This is an old version of the DLL, and we go into the properties, take a look at the details, and you see file version 0000. This is the old part of the workflow. And now let's take a look at our new one. You see, drop files to drop location. It's now creating the files at the drop location, and we are done. And it's getting more and more interesting. Let's see. Go to build. Complete it. This is our new build. Download drop location. Open it up. Drop. Take the same DLL. Let's copy it again here to documents. That's fine. Replace the old one. And crossing fingers. Details. Here we are. Yes, it worked. You see? I mean, a lot of work to change 4 zeros into a different number, but I hope you get the point. The idea was to build an entirely customized workflow, to add our own components, to do the deployment automatically into the cloud. So we now have a really customized continuous integration and deployment platform built on Team Foundation services and Windows Azure websites. I hope that this session gave you some new ideas, that you go home and maybe think about using TFS on-premise, more TFS in the cloud, Windows Azure websites in the cloud. I hope it was interesting for all of you. I really encourage you, it's super important for us. We as speakers invest a lot of time preparing these sessions. I really encourage you, go to the booths and give us the feedback. Tell us what we did right, tell us what we did wrong. I would love to hear your feedback after this session. I will be here for the rest of the week, mostly in the Windows Azure area, in the MVP area, in the Ask the Expert session. If you have any questions about Windows Azure or TF services or continuous integration or our development practices in our own company, just grab me on the hallway and ask me your questions. I'm here to answer them. I wish you a beautiful afternoon and evening today at the party and a very successful TechEd for the rest of the week. Thank you very much for attending this session.